We're on exponential graph. So generally we have two forms of exponential graph. So the first one, that's the blue graph, and the red graph. So it depends on the base. So we know that the exponential function is always y equal to a raised to power x. So this is also y. Okay, let me use. This is when a, that's the base, is greater than 1. Why this red graph is y. Okay, let me change the color. This is when y equal to a raised to power x. A is between 0 and 1. Though we have when the base is 1, because as you can see, they intersect. That's the general form. It must intersect at 1. So this is y equal to 1. This is when a is equal to 1. So, but we don't normally consider the third one, because it's a straight line. You can take it as equation of line. So we are looking at the red graph and the blue graph. So let's look at the second graph. So when we plot more than one exponential graph using one axis, you can easily guess the particular base. The one closer to the y-axis, the base is always greater. Remember, these three graphs, a is always greater than 1. So, but the base, assuming, okay, maybe let me do it y. The red one is y equal to a raised to power x. Like, let's take a1, a subscript 1. Y, the green one, let's take it as y equal to a2 raised to power x. This is y equal to a raised to power a3 raised to power x. So in all cases, a is greater than 1. But you can easily see that whenever you have three graphs or more than one graph like this, the base, the one closer to the y-axis, is always greater. So I'm saying that a3 is less than a2 and is less than a1. So that's it. The one closer to the y-axis is always the greatest. So coming to the second one, remember, we have that this is the graph. This graph is always this graph. The base is always between 0 and 1. So again, we have so the one closer to the y-axis, let's call it y equal to a. Okay, I used a1. Okay, let's use a1. Y the one, the second one. Let me use y equal to a2 raised to power x. Y the last one, y equal to a3 raised to power x. So, but here, the one closer to the y-axis is the smallest. That's the base is the smallest. So we have that. Now a1 is less than a2, is less than a3. Okay, we have 6 graphs. This 3 is when the base is greater than 1. Why this is when the base is less than 1 but greater than 0. That is between 0 and 1. So from here we see that this is y equal to 6 raised to power x, y equal to 5 raised to power x, and y equal to 4 raised to power x. Because the nearer to the y-axis, the greater the base. Why this is y equal to 6 raised to power minus that, y equal to 5 raised to power minus x, and y equal to 4 raised to power minus x. Yes, because here a raised to power minus a means 1 over a. So that's it. Okay, if f of s is transformed to get g of s, then gs is what? So we should know that exponential graph, the parent graph is either this or that. So this is y equal to a raised to power x, where a is greater than 1. That's the base is greater than 1. And here, a raised to power x, here in this case, a is between 0 and 1. So that's it. So in this case, fx will be formed a is greater than 1. That's why the bases are greater than 1, not between 0 and 1. So again, the intercept must be 1. Yes, at this point is 0, 1. So that's it. That's a parent exponential graph. So if you reflect this if here is 0, minus 1, so it will reflect this. So the equation, the function is now minus a raised to power x. Do you get? So that's what you have to know. It reflects is now negative. So, and again, there's what we call horizontal and vertical shift. If you have a function y equal to plus or minus a plus or minus, okay, let's read minus fx plus or minus b, that a is the vertical shift that's moving up or down. So the positive is up, y negative is down. Here b is the horizontal shift. So negative is right, y positive is left. So we'll now combine everything. As you can see, there are major points here on this line. Let's map out the major grid line. See, this is a grid line. That's major grid line on the where the graph are on the major grid line. So these 3 points will help us to solve this. As you can see, the first one help us to recognize this as an exponential graph. And if we now reflect, we now have that y must be minus fx based on this. And if I now move, for me to get this of g of x, I move this one unit up, and now move 1, 2. So we are saying that this graph will now be 1 unit up, which is 1, plus 1 up, plus, because okay, it should be minus, this is now minus fx, minus, no more plus. So the minus, if you have minus here, it means reflection about the y as about the x axis, not y axis. So this is minus 1 minus f x. We moved 2 units. So our main aim is now to guess fx, because they gave us the actual exponential graph, not just fx. So how do you get it? Since we know that fx, as at this point 1, 2, this graph, you know, is fx equals a raised to power x, as you can see. So at this point, y is 2, x is 1. So what do you have to say? A is 2. Therefore, this one, this of g of x, we are looking for will now be 1 minus a raised to power x. And a, okay, we've gotten a as 2, which is 1 minus 2 raised to power x minus 2. So that is the answer. Our answer is option B. So it's a very tricky question. So this is very important point in a exponential graph. So if I move 1 unit up and move 1, 2, 3, 4, I get another grid line. So we see that the answer will be C, yes. Because if you have a function fx and you have another function plus or minus a plus fx plus or minus b. So if I shift a vertical, so that's a. Plus means up, minus means down. While here plus means left, here right. B is the horizontal shift. So that's why we have 4 units, 1, 2, 3, 4, and 1 unit up. So that's the answer C.